Hi everyone, this is Sayana, Assistant Professor, Department of Electronics and Communication, VASSA Institute of Science and Technology. Let's have a discussion about Wi-Fi 6E, which is the extended version of Wi-Fi 6. Now let's see what is Wi-Fi 6E. Wi-Fi 6E is the latest standard in the industry after Wi-Fi 6. This has faster speed and lower latencies than Wi-Fi 6 and the earlier iterations. This is obtained by adding a new band to the existing 2.4 GHz and 5 GHz, which is 6 GHz. That means we are adding another band 6 GHz. The band allows for speed up to 1 gigabits per second. Since the spectrum uses short wavelength, faster the data transfer occurs. It significantly reduces the traffic in the network. Now let's see what is Wi-Fi. Wi-Fi is actually wireless network protocol. It is based on IEEE 802.11 standards. It is used for local area networking of devices and internet access. Actually, Wi-Fi or IEEE 802.11 standards are introduced by US Federal Communication Commission in 1985. It allows nearby digital devices to exchange data by radio waves. They are used globally in home and small office network to link computer system to wireless router to connect them to the network. Now let's see how does Wi-Fi work. As you can see here, a computer, a modem, another computer and a mobile. As the name suggests, communication is wireless between the equipments. The wireless communication happens between user computer and a wireless router by means of radio waves. In this figure, you can see a center computer, and from center computer there is a modem which does the modulation works. This links to another thing, internet service provider. That means they are providing the internet to us. This is connected to another internet service provider through a data transmission cables. The last internet service provider is the service provider of the receiver. From this, the data are sent to modem of the receiver and then to the receiver computer. This way the communication happens. Now let's see the generation of Wi-Fi. That means IEEE 802.11 standards. The first Wi-Fi, that means Wi-Fi 1 is 802.11b. Next is Wi-Fi 2, that is 802.11a. Next one, Wi-Fi 3, that is 802.11g. Wi-Fi 4 is 802.11n. Wi-Fi 5 is 802.11ac. Wi-Fi 6 is 802.11ax. And then Wi-Fi 6E is 802.11ax. Let's get into Wi-Fi 1. Actually, Wi-Fi 1 is the standard IEEE 802.11b. Wi-Fi 1 devices operates at 2.4 GHz frequency band. That means only one That means only one band of frequency is available. Wi-Fi 1 supports coverage distance of about 38 meters in indoors and about 140 meters in outdoor environment. That means 38 meters in indoor and 140 meters in outdoor. Next is Wi-Fi 2. The standard for Wi-Fi 2 is 802.11a. Here we introduce the multi-carrier modulation scheme, that is OFDM, which supports high data rates unlike single carriers used in Wi-Fi 1. Wi-Fi 2 devices operates at 5 GHz frequency band. Now we are looking into Wi-Fi 3. Wi-Fi 3 is the mixture of Wi-Fi 1 and Wi-Fi 2. That means its standard is IEEE 802.11g and it has been developed to support frequency bands of both 11b and 11a. It supports 2.4 GHz and 5 GHz frequency bands. It supports all the features as supported by 11a and 11b standards. Next is Wi-Fi 4. The standard 802.11n is referred to Wi-Fi 4. In this Wi-Fi standard, MIMO and beamforming has been introduced, but the interoperabilities have not been tested. What is MIMO? MIMO is multiple input, multiple output. That means it uses multiple transmitters and receiver to transfer more data at the same time. Similarly, beamforming is focusing wireless signal to a specific receiving device rather than spreading the signal in all directions. Next is Wi-Fi 5. This Wi-Fi 5 is IEEE 802.11ac. In this, beamforming has been added to the MIMO and multi-user MIMO feature are also introduced. Wi-Fi 5 supports higher throughput due to addition of higher bandwidth. Wi-Fi 5 operates at 2.4 GHz and 5 GHz frequency bandwidth. It supports single user transmission as well as multi-user transmission much more efficiently than previous generations. Now Wi-Fi 6. The standard IEEE 802.11ax is referred as Wi-Fi 6. It offers higher speed and greater coverage. Wi-Fi 6 operates at 2.4 GHz and 5 GHz frequency bands. Here the OFDMA concept is introduced in both uplink and downlink direction. It creates independently modulating subcarrier within frequencies. This allows simultaneous transmission to and from multiple clients. And the last one is Wi-Fi 6E, that is 6 extended. Wi-Fi 6E adds support to 6 GHz spectrum plus faster wireless speeds and lower latencies. This simply means that there is now a new frequency band of 6 GHz, which allows for faster data transfer rate. Until Wi-Fi 6, we had only up to two frequency bands, that is 2.4 GHz and 5 GHz. But this caused slowdown in network as more and more devices connected to that same network. By the introduction of new 6 GHz band, when more devices connected, data can be passed through this less congested and faster band. Here is the example. Here we have 2.4 GHz band and 5 GHz band. Now we introduce a 6 gigahertz bandwidth. So we can transfer the data in much faster rate. Now the future scope. Wi-Fi 6E is the most advanced standard for wireless communication till date. But there are newer standards being developed and tested such as Wi-Fi 7. Wi-Fi 7 is said to be incredibly faster than the existing generation of Wi-Fi. That means it is 4 times faster than the previous iterations. It will also provide multi-link capability, that is, the device can connect to more than one network at a time so as to improve the network connectivity. So that's all about my presentations here. Thank you.